So I'm Pat, and I've been doing this since I actually had hair. And I've spent a lot of my spare time thinking about eventual consistency transactions, what the hell this junk means in a loosely coupled world where things fail and things you want to, and they're replicated and all sorts of weirdness happens. And so I slightly changed the title of this to be Subjective Consistency. And when I was deer in the headlighting trying to get it actually cohesive, I called on my friend Sheldon Finkelstein, and Shell helped me tremendously. And so I list him as a co-author. And so I want to start by saying A Foolish Consistency is a Hobgoblin of Little Minds by Ralph Waldo Emerson. So the outline is introduction. Has acid been neutralized? Consistently stretching the truth. Solipsistic introspection, and I will explain that later. Coping with your selfish ways, and conclusion. Let's do the introduction. So what's the acid test for consistency? You know, my dear friends Jim Gray and Andreas Reuter defined this stuff as atomic is all or nothing. Consistent means the transaction is correct, no integrity constraints are violated, and that's the weakest of the understanding of the acid for properties. Isolated is transactions appear to execute in a serial order, and we will talk about the funkiness of consistent and isolated quite a bit. And durable, once complete, the transaction survives failure. So the definition of consistency in the monumental tome that I love is a transaction is a correct transformation of the state. The actions are taken as a group, do not violate any of the integrity constraints associated with the state. This requires that the transaction is a correct program. I loosely translate that as it's consistent if you don't think you are insane, subjectively. So acid transactions are pretty damn well defined in a centralized database, and you want to talk about isolation in the read and write semantics because they were started to define it with respect to relational databases. And distributed transactions approximate acid behavior. But the problem is they stop in a classic two-phase commit. They stop when you lose a system. And when they stop, you may have locks held by the in-doubt participant, and then people lock up behind the locks, okay? And so I wrote a paper, I think 2007, called Life Beyond Distributed Transactions and Apostate's Opinion. But that breaks both durability and atomicity, right? If the second biggest challenge is what does it mean if you lose a server, like it burns up, it's charred toast, okay? Then you no longer have atomicity, and you now have a funky notion of durability because it committed in one place and not in another. So there's looseness here that's funky. But on the good side, acid transactions are way the hell easier to program. The guy's used to a database, the gal's used to a database, they just program away, they party on, they commit. Life's easy, life's good, except when it has availability challenges. So classic isolation, we're going to go through this quick, right? There's this notion of read uncommitted, so you can have dirty reads and non-repeatable reads. And a phantom is when you're scanning through a set, and then you go back and you look, and now there's a new record that was in there when you were looking through a set. That's called a phantom. And so there's 4 levels that are classically defined: read uncommitted, read committed, repeatable reads, and then finally serializable. In a classic non-distributed centralized database, if you have serializable behavior, serializable, it doesn't say that the transactions are serialized, but it says that you can look at them as if they happened one at a time. So if there's 2 that happen at the same time, they can't see each other. Okay? So that's the classic notions of isolation, which give you a notion of consistency, assuming the application isn't tangled up in its underwear by itself. Okay? So database isolation was defined in terms of the relational model. And it even says so, right? If you look back at the classic paper that defined it, it says, for definitiveness, this section is couched in terms of the relational model of database. Reads, writes, and scans of records are isolated from each other. I'm emphasizing consistency and isolation in classic transactions is assuming you're standing on top of a database. Does that make sense to everybody? And so we're going to talk about those assumptions being not quite what we do moving forward. So database-centric and centralized. Isolation semantics over database was really hard. I know these guys, or knew them, right? And they're brilliant, or were brilliant, and so they still did not address the new models that stretch consistency. How the hell is consistency being stretched? Well, it's being stretched in a bunch of different ways by new computational patterns that weren't even thunk of back in the day when my predecessors were defining this brilliant work. And so they didn't consider many modern challenges. Loosely coupled systems. I grew up building systems. You had the database, you had the app, and then there was that stuff those data communications guys did, and who gave a darn? Okay, they were strange anyway. You meet them and they had talked about weird things, right? You didn't think about the data spanning those environments. Now we have this world where we're doing loosely coupled apps across businesses, across departments within the same company, okay? Replicated. That's where you have a multi-master service with many replicas. They're doing the same work. They coordinate and resolve to the same state. We talk about being eventually consistent, and I'll talk more about that later on. When you have multi-master replicas, maybe you have 5 of them, you don't have to find more than one of them. You find one, you do your work, he takes care of the difference. They squirt it around, make it all happen, and that's how a multi-master replicated system works. It efficiently messes with isolation and efficiently messes with consistency, and you have to have other models to deal with it. This is one you probably haven't heard of, but it's just brilliant work. Open nested transactions. You have a layer of abstractions. And so when you're doing a transaction at the top layer, you're saying begin, work, 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 end. That work calls down to some lower layer of abstraction, which takes its state and transforms it from a consistent state to another consistent state, and then answers. So far, so good? Now you come along and you're cruising along, and the top level says, oh, I need to abort. And so you undo the operations. And so you call the lower layer, and you take it from a consistent state to a different consistent state. In between those transformations at the lower level, there may have been side effects. Doesn't matter to the top level, doesn't matter to the lower level. Very important concept. We'll dig into that more. Put a cap on it. Most of us are familiar with the cap conjecture followed by the cap theory. Consistency, availability, partition tolerance. Consistency is defined as classic acid consistency. How do I party on top of a database? Availability, does the whole distributed system continue? Partition tolerance, what happens when either multiple systems cannot talk to each other or some of them are down? They end up looking the same. And so the cap conjecture, in theory, says there are 3 properties, pick 2. You can only have 2 of the 3 at one time. And so the cap conjecture was defined by Eric Brewer, or posited by Eric Brewer in 2000. The cap theorem was proved by Seth Gilbert and Nancy Lynch at MIT, proved the conjecture in 2002. If you assume reality, which means computers will fail, and sometimes you can't talk to the other ones, so I assume you must have partition tolerance or you are living in la-la land, okay? You have 2 choices. You have consistent and partition tolerant, but when you lose one, you stop, okay? Or you have availability and partition tolerance. When you're normally running, you must deal with the fact that you get weird, funky answers, okay? And we have to define ways to rationalize what happens with those funky answers. Is this making sense to everybody? Okay? So we are only paying attention in this talk to the I'm available, I can have partitioning, and what do I do about funky answers? Because I don't have the classic notion of consistency that you get from databases. You have a different notion of consistency. And we're going to explore how real-world applications deal with different notions of consistency. Subjective consistency. This is a term I made up, okay, with Shell. Subjective consistency. Given what I know here and now, keep track of what I know, and then do some action. I got to remember the state because it may depend upon who you are and your authorization. Remember the significant dependencies that were used to decide. Now, what's significant is up to you, right? And there's an intent of the decision, and Shell has a paper he wrote called Transactional Intent. Other nodes, loosely coupled or replicated, may make independent decisions. My evil twin in my replica set might do something independent of me, and now I got to deal with it. Okay? My loosely coupled system, where I'm in this department and he's in that department, or I'm at this company, he's at that company, may make their decisions, and we have to work it through and sometimes apologize, and sometimes, once in a while, rarely, fuss to a human being to clean up the need for an apology. Subjective consistency is necessary, hard, and achievable. Order entries, ticketing, calendars, supply chains, manufacturing, they all do it. This is what happens. They just don't run and say, I've got database consistency and there I am happy. They figure this out because they have to deal with it. It requires a strong reactive framework to deal with application changes and new apps. When you talk about asynchrony, when you talk about synchrony, they are always with respect to something. I remember the SQL Server system at Microsoft. There were threads, classic operating system threads, and there were, what do they call them? I forget. But there was a little notion of a temporary thread that you could set aside. So you had thousands and thousands of the little temporary ones. You would stall them to do an I/O, and you would not stall the actual operating system thread because they were too precious. You would pick it up. So an I/O was subjective with respect to the little device. It was not subjective with respect to the operating system thread. Asynchrony and synchrony are subjective terms. This typically, when you're building applications, you have a transaction within each of the constituent systems, and the work you're doing is asynchronous with respect to those transactions to make a longer running business transaction. So subjective consistency, given what I know, make a decision, act on it. Remember what I know. Has acid been neutralized? What's with the A? A? The A in acid means atomic, all or nothing. When you get married, you are either married or neither. If you get married over the phone, it's difficult. Suppose you say, I do, and then you get a dial tone. The real question is, are you allowed to date? Okay? So this is what a two-phase commit transaction is like. Distributed transactions using classic two-phase commit are brittle. When one server is down, transactions are in doubt, which is like, I do, dial tone, okay? Other transactions can get stalled behind those locks, which are holding database records, waiting to see what happened. Application falls over in a heap of rubble. The application architect gets fired, and someone comes in to do something else. And that's what's in that paper. And how to do that is in the paper, Life Beyond Distributed Transactions, in Apostate's opinion. Another way of thinking about this is if you only two engine airplanes have twice as many engine failures. If you can only fly on one engine, that's a bad thing. Okay? And so that's what two-phase commit is like, a two-engine airplane that can only fly on one. I can see lots of different ways. Loosely coupled participants interact with autonomous actions. Each participant has independent state, performs local transaction. Protocols connect participants doing business as they execute workflow. Replicated participants have copies of the same info. They track changes, they may be out of sync, they make decisions, they say, oh my, this is a problem. Open-nested ones work at different levels. Work at each level, commits a transaction, you abort an upper layer, and the lower layer needs to compensate. Side effects at the lower layer may persist, and that's fine. All of these causes changes to the consistency model. They change it individually, and they change it in combination. I am alone as far as I'm concerned. Classic applications are about running a single app running on top of the database. The isolation allows concurrency of different apps, threads as they appear, serializable isolation truly makes concurrent database access seem like nothing else is happening. Honest to God, you're running on top of a database, you're whacking on the records, you don't see anyone else. It works. It's pretty cool in a centralized system. But isolation is really weird when you have replicas. You did something, your evil twin did something, what the heck happened? Isolation is weird when you're running loosely coupled partners. You have to commit your local transaction before you send a message. Let me make sure everyone hears that. I'm making a decision. I'm one of 3 loosely coupled participants. I want to send a message. I must commit my transaction locally before I send a message, or I can send a message, crash my transaction, and not know what the heck happened. So nobody does that. or they get fired and somebody fixes it, okay? You always commit, then you send. He gets the message, he takes the message, he does work, he commits, then he sends. That's how you compose these things. Isolation is weird with open-nested partners. Your internal, perhaps loosely coupled building blocks have their own way of seeing operations. Is the deed really done? It used to be easy with durability. I remember building it in the early 80s, man, it was really interesting. You had these centralized systems where you know when did it make it, it got to do with the log write and that commitment of that because I could put it back after a crash. Running on a single system, it was durable. Again, when was it durable? We added mirrors, we added disaster recovery, we added more. When was a transaction durable in the face of these things? Application failure. Okay, that's pretty easy. System crash. Okay, that's pretty easy. What, fire, tornado, earthquake, plane crash, flood in the data center. Gee, maybe that transaction didn't stick when these things happened. Okay, I'm going to send it to another data center. Okay, is it durable in the face of thermonuclear exchange, and do I care? Okay, these are interesting questions. Durability is not the same as atomicity. You can atomically lose a transaction a week after it's committed. So it's not durable, but it was atomic. Atomicity is related to durability because I'm in a loosely coupled system and I think I'm atomic, and then he loses his mind and he's gone. So I'm no longer atomic because he's not durable. Okay? So these are interesting questions. So the point is, acid's kind of got its issues, right? It's brilliant, but it's got its issues. So let's look at consistently stretching the truth. Loosely coupled apps have multiple independent components. They're defined and implemented separately frequently. I'm walking from one bank to another bank. They wrote it, I wrote it, that kind of stuff. They may run on different systems for different businesses. They may cooperate to perform long-running work. Loosely coupled applications run multiple transactions on messaging. The app performs a transaction for each message, as we said. Each app component remembers the messages it sent and retries. Okay? So if you haven't gotten an answer, you send it again. Okay? And so that means that you're going to get at least once delivery of the message. Over here, he's got to be prepared to get multiple messages, so he has to be idempotent. Idempotent means it doesn't mess up if you get more than one message into you. Okay? Now, if work is sent out, being in a transaction, we may lose the effects of the message sent. I cannot do begin transaction, message, and then try to do end transaction. Because I may croak, I don't remember I sent the message, and it's bad juju. Okay? So you always commit and record the intention, and then keep trying. Okay? So you have to have a mechanism like that. Each application has to be idempotent. So loosely coupled applications often have very different implementations. They work together even though they're like really different and really strange. This is why we have seen the emergence of things like XML and JSON, because they are designed to allow understandability across boundaries. Okay? Dramatically different than relational systems, which are all inwardly focused and intimate. Many-me, multi-master replication. So, multiple replicas of the application run on different servers. Each of these is capable of taking independent actions. Over time, they tell each other what they've heard. Hopefully, as they hear, they can resolve those differences. They run multiple transactions based upon multiple interactions. I do a transaction. My evil twin does a transaction for the same thing. My evil triplet does a transaction for the same thing. How do we put it all together without getting tangled up? And hopefully, the guy on the other side, your partner, who's dealing with this family over here, can't tell it's replicated. That's the hope. They're just dealing with it like one thing, and they can't tell, and the reason for the replication is both scale, but even more for resilience. Applications which are multi-master replicated are actually pretty darn hard. Okay, it's hard to build them. They need to deal with partner applications, just the loosely coupled stuff, but they have to deal with the evil twins that may have done stuff. And business rules to a complication, that lubrication, that facility for defining consistency and isolation differently have to be thought about carefully. Okay? Open nesting, or myopic abstractions. I like to say the more nearsighted you are, the less you care about that junk. And the less you care about that junk, the more you avoid getting into trouble. Operations are performed and answers are received by the lower supporting app or component or whatever we want to talk about it. And the same things can apply to things running in process as things running across the web. We'll talk about that. Encapsulation hides details and side effects from the top application. So interactions across open-nested relationships may be intra-process or via messaging. Each operation in the transaction is implemented by calling lower level stuff. Multiple separate higher level applications may concurrently work with the lower ones. So I'm chugging along and I got this transaction at the high level, I have a different one, and they can call into this lower level one as long as he can keep them isolated in a proper fashion. That's okay. I'll give you some fun examples later on. Open nesting means don't sweat the details. Don't understand the stuff you don't have to know. Sometimes that higher level work leaves lower level side effects, and it's okay. The higher level abstractions are consistent after abort. The lower level abstractions are consistent after abort. Can you hook these together? Let's look at loosely coupled, replicated, and open nested. Well, if you don't have either of them, any of them, then it's classic standard. Layered abstractions on a single system in open nested. Replicated but not open nested or loosely coupled, that's not terribly applicable because why replicate if you're not talking to somebody loosely coupled? And similarly, it doesn't work there. Loosely coupled, without the replicated and open-nested, sure. Loosely coupled with open-nested actually helps because the layered abstractions are going to lubricate things. Loosely coupled and replicated, complicated, but it works. And loosely coupled, replicated, and open-nested is in fact one of the most common ways you deal with loose replicated stuff. If you're replicated, you got to be loosely coupled at some level. Open nesting helps with that. Solipsistic introspection. Shell helped me find this word. He is more of a word nerd than I, and I'm a word nerd. Okay. So solipsistic is of or characterized by solipsism, or the theory, the philosophical theory that only I exist and the rest of the known universe is a figment of my imagination. Okay? So let's look at introspection with respect to the belief that nothing else in the universe exists other than I. Open nesting, tentative operations, and commitments. So different apps communicate to broker deals. And as they communicate, they accept tentative work, and they got to figure out what you're going to do with it. This is not any different than making a reservation at a hotel, getting an airplane ticket, which may get canceled. There's a lot of things that occur with this. And if canceled, the application has to deal. When a tentative operation is canceled, somehow the invoked service has to compensate. It can't undo. Everything's been unlocked. It has to compensate by doing another forward piece of operation. It's another operation that makes things right. To support tentative operations, the application has to ensure that they're cancelable. And the main trick here is commutativity. You can reorder the cancellations, with each other's work. And sometimes you can let the other party see some effects. Many of you know that when you go to an airline, the first 85% of the seats, you can get a specific seat assignment. And the last 30% of the seats, you just get a guarantee to get a seat, okay? And my math was correct, okay? 85 plus 30 overbooking, counting on people not showing up, counting on giving those seats away. Is that transactionally consistent in a classic way? Heck no. Is it important to not have empty airplanes? Yes, okay? So compensating work is the hallmark of open-nested transactions. I have loosely coupled stuff living in their abstraction, and they're supporting different layers of abstraction and compensations. Sometimes the loosely coupled apps are not open-nested, but they cannot do all the complex long-running work. Open nesting defines the internal behavior of the app. Every time you take a tentative operation as one of the participants, you get more confused. I have no clue what's going to happen, and now that I've taken that piece of work, I have less of a clue as to what is going to happen. Every time you confirm or cancel, you get more confident of what will happen because the uncertainty is now reduced. And so in these kinds of systems, you're walking around with this increasing and decreasing level of uncertainty that you must cope with as you think about your inventory, as you think about the hotel reservations, as you think about the seats on the airplane, which then imply a lot of other things in terms of fuel for the airlines and whether you cancel a flight. So I like to think about bounding your uncertainty. You know the worst case, you know the best case, right? And you know this wonderful bell curve in between of where you think you're likely to land based upon the tentative work that you've received. Again, tentative operations move the lowest and highest values apart. So as you take a tentative operation, your bounds get bigger. As you have a cancellation or confirmation, your bounds get lower. Let's talk about escrow locking and CRDTs. I'll tell you what that is in a sec. Escrow locking is locking with a commutative operator. So, and you're logging and you're doing undo by operator. A friend of mine published this in '86, at the ACM TODS, Transactions on Database Systems. And in 1988, Franco Puzzolo, who, by the way, was a brilliant engineer, chief architect of the first five of the first six SQL systems in the world, a great friend. He implemented escrow locking with me for addition and subtraction in the SQL operators for Tandem's nonstop system. So when you did an addition, you would log in the log, not the new and old value of the record. You'd log, I added 10, okay? And so as you would then do a subtraction, you subtracted it and you keep track of the worst cases. And if you did an undo for an addition, you would subtract against the current value, okay? That actually allowed us to really go well on the TPC-B benchmark where we're having isolation conflicts on the branch record for the banking application because you could add and subtract the value of the branch by doing this. And so this is a centralized local system, use of commutativity to get increased concurrency with a different notion of isolation. The isolation wasn't read-write. The isolation was an operator, okay? So CRDTs is some recent work, that's been coming out, first published in 2011 out of France with Mark Shapiro, who I know, and some other folks. Strong eventual consistency. So I don't know what I don't know, right? But it's a commutative, replicated data type. Commutative, replicated data type. And there's two subsets, convergent, where the state is shared, and commutative, where operations are shared, and the results are equivalent. So this is research work in how you can define data types and items so that you can operate on them in a replicated environment and put Humpty Dumpty back together again with predictable behavior. I speak of commutativity with respect to invariance. And by the way, I don't use any of this in my day job. This is literally what I do for fun, so I'm weird, okay? Commutativity with respect to invariance is the ability to reorder the operations being performed. An invariant is a business rule. Don't book more than 115% of the seats on an airplane. Okay, that's a business rule. What's my overbooking level? Some business rules remain true from the application's perspective. You must have it true even though you're allowing commutativity of the operations. So commutativity with respect to an invariant is I can do reordering, and when can I do reordering without breaking the business rule, and when can I put Humpty Dumpty back together again by knowing what I did and how I'm going to clean it up. So that goes back to that subjective consistency. Remember what I did so I can clean it up. Loosening up the ordering while preserving the business rules. Example invariance. Don't overbook the airline by more than 15%. Schedule just-in-time shipments. The sum of my bank account must be greater than 0. By the way, debits and credits work just fine with lots of reordering, but when they hit the bank account, they don't want them to go below 0. Looser invariants allow more commutativity. Managing concurrency with business-specific invariants. Overbooking versus over-provisioning. Overbooking is I promise stuff that I don't know I can give you. That allows me to do more and optimize my system if I don't mess it up. Airplane seats, overbooking. Sometimes it results in a failure to fulfill. On a whole, it results in better average efficiency. Over-provisioning. Never promise something without setting it aside to ensure you got it. Can't completely utilize all your stuff because not everything's going to happen. So it's conservative, but may waste resources. You may choose to do this if keeping your customer happy is the optimal thing for your business. You may choose to overbook if the efficiency of the throughput is more important, which then, of course, results in better prices for your customers. Choices, business choices. Selective consistency. What's the cost? If you deposit a check for $100, no hold on the small check, Funds are right there. If you deposit a check for $50,000, they are on the phone. Dude, is there $50,000? Can you lock it up for me? I'm depositing this check. You call the home branch, you verify the funds. Cost benefit associated with incomplete knowledge varies. Not so much cost if you lose $100. A lot more cost if you lose $50,000. So that's why there's differing behavior to deal with that uncertainty. Now, Shell and I defined in 2007 ACID 2.0. So ACID 2.0 is associative. A plus B plus C equals A plus B plus C. Commutative, A plus B equals B plus A. Idempotent means I can do the work many times, and distributed, it's spread out. So the point behind ACID 2.0 is you can't tell the order in which the work is done. You can't tell how many times the work is done. But if you design to these design principles, then it's just fine. Okay? It's fine that you've got this lack of knowledge about the order and lack of knowledge about how many times it's done, at least once. So for the goal of the new ACID is to recognize the work will be done by lots of unreliable machines, different sizes, shapes, purposes, deployments. This is, by the way, very much like people in societies. People are made up of cells, and they can fall over and die, and it's okay. In societies, the reality is that when people die, hopefully the society continues on. This is just kind of part of how it is. So I blogged about this and wrote this in a paper before. Memories, guesses, and apologies. Computers will have partial knowledge because they know what the computing version of it is. They don't necessarily know what the reality behind it is. You don't know that the airplane got a dent and so it's not going to fly because nobody's told you yet, okay? Computers make decisions on partial knowledge, but sometimes they don't stick. The best you can do is guess. You might have a good guess, you might have a bad guess, but you don't actually know what you don't know. Now, it's really nice to remember your guesses. It actually gets you closer to doing useful behavior, right? It makes it easier when you guessed right, easier when you guessed wrong, and computers usually remember their guesses. So the fidelity of the memories is closely related to the cost. If you spend more money on replicas and fancy disks and more data centers, you're less likely to lose that knowledge. The longer latency, though, to share knowledge across those replicas. So investing in remembering well is a business decision. Maybe it's cheaper to forget, but then you have to cope in your application with, he told me this stuff and now he doesn't remember what the hell happened, okay? So all of these are okay. What's essential is that you understand this is what you're dealing with in a loosely coupled distributed system, because welcome to Einstein. He said you can't quite know what's happening over there for a while, right? And so that is part of what we deal with. Sometimes you make a guess based on incomplete information, and if things go wrong, you have to apologize and tell your loosely coupled partner they are out of luck. Gaps in memory. I'm replicated. Client can write to any one or more of the replicas, and the work eventually happens. You share your knowledge. The replicas converge on the same answer if they're designed correctly. So here, I have 4 replicas of application A, and I have 5 partners, B, C, D, and E. There's a loosely coupled A through the other letters, but inside of A, he's got an evil quadruplets, okay? So B sends the information just to A1. C sends it to A1 and A2. D does some work with A4. E, again with A4. F with A4, A3, and A2. Anytime each replica has a subset of the knowledge, your evil twin, triplet, or quad has done something you don't know. So this is time going from left to right across those 4 replicas. B hits A1, and then he works his way to A2, A3, and then a long time later to A4. C comes along, and he's written to 2 places. He's written immediately to A1 and A2, although that has its timing issues also. But then he replicates to A3 and A4. D comes along, and he gets written to A4, but it takes him a while to get it to 3 to 2 to 1. E is written to A4, and he has to work his way through those also. F, written to 3 of them, but then has to get to the 4th, and the first 3 are actually happening in different timings as they hit that other system. So as time moves forward, your knowledge is a mess. People know stuff that nobody else knows. Things come in out of order. It's not easy to reason about what you've found and what you've heard. Incomplete knowledge can make for questionable guesses. I'm guessing at one of these replicas. I don't know all of what's known with my evil quads, okay? Nothing is guaranteed to stick until known and accepted by all replicas. But myopia can provide clarity. Open-nested transactions give the interactions of different layers as work is performed. Lower layers commit as a part of the upper. Failure and undo does not automatically undo the lower layers. You have to drive back and call for another lower level transaction to compensate for the fact that you're not keeping the first work of it. And it's logically undoing it. So this was written, by Elliot B. Moss, and he's just a beautiful paper called Open Nested Transactions, Semantic and Support. So let me give you a great example of this. I have a database transaction, classic one you probably learned about in school. I went to school before they had to teach it about it, okay? Because I used to have hair. And so database transactions and B-tree block splits. So transaction T1 comes along and it inserts record X. Great, so you call the B-tree guy. And he runs down and he says, I got to squeeze this into this block in this key range and I'm going to get it in there. Darn, the block's full. Thunk, let's split the block. The way it always works in the B-tree stuff as you're running under a pretty normal database system today. So you've done that, and you've inserted it and split this, but the high-level record-oriented stuff, he didn't know anything about the block split. He just said insert record X. Now he comes along and says, oh, darn, I'm going to abort. So you come back, and you call delete record X. And that goes into the block split environment, into the B-tree, and it finds X, and it deletes it, but it doesn't undo the block split. Okay? Other records might have gotten in there, other records may have gotten in there. It doesn't undo the block split as a part of undoing the transaction. The block split's left. The higher level is database transactions and records. The lower level is B-trees, blocks, and records. Make sense to everybody? Okay. Another example, I'm going to take a trip to Paris. I'm going to reserve a hotel room in Paris. And the hotel says, oh my gosh, now there's a lot of people. That one additional reservation, a lot of people. Let's make more food for the restaurant, get more people for the restaurant. Let's get more food. The restaurant says, okay, let's call the greengrocer and get another shipment. And the greengrocer says, that's great. Let's call the shipper and schedule another shipment. And the shipper says, that's great. Oh my gosh, I predict that a week from now, I'm going to be running out of diesel fuel. Let's go and order some more diesel fuel. And then I cancel my hotel reservation to Paris. That doesn't unwind. There are legitimate and correct side effects. The higher level is travel, airlines, and hotels. The lower level is hotel and supplier operations. And there's in fact more lower levels as you get to the greengrocer and the shipping company. Those side effects persist as they should. And at the high level, you have no stinking clue. I have no idea when I'm reserving and canceling a hotel reservation what craziness I caused. Ignorance is bliss. That is open, nested transactions. So how do you cope with your selfish ways? I'm inside of me. How do I deal with you being annoying, okay, and doing things that are annoying to me? Well, I like to talk about apology-oriented, is a term I made up. Apology orientation is the recognition that the application lives with uncertainty. Anything and everything done by the application is probabilistic. When new information comes, you got to think about, oh my God, did I do the right thing before, right? Sometimes the application needs to say, dude, I'm sorry. You are not getting on the airplane, right? It's not going to happen, right? Or you can't have the widget, okay? Receiving an apology is really a drag. Now what am I going to do? Amazon says, sorry, the book's not coming for a month. That stinks. But apologies are inevitable in real life. The car was totaled in a car accident. It's going to take some time to deal with it. So I wrote a paper called Building on Quicksand, which actually explores the semantics of asynchronous checkpointing. And it talks about the fact that when you are asynchronous in your checkpointing, you are intrinsically probabilistic. Okay, asynchrony, and you guys are all about asynchrony. Reactive, it says up on the marquee, asynchrony. Asynchrony means confusion. Confusion means reason about how to deal with the confusion. Okay? Love means never having to say you're sorry. Hogwash, I'm married, I know better. Heuristic commit and heuristic abort. I remember these when I was a kid, right? I remember it from CICS, one of the original distributed transaction system. Commands in some transaction systems to automatically time out and commit or abort a two-phase commit. I promise to wait for you to decide what happens to this transaction. Oh, damn, to hell with it, I'm going to commit. Okay, that is heuristic commit. Or, oh, damn, I'm going to abort, right? And that's heuristic abort. It breaks the transaction's atomicity, but it does mean that the records are still around to get confused because of the bizarre work you've done. I like to call heuristic commit the two-faced commit protocol. Now, this one's one of my favorite slides. Apology-oriented computing. I'm sitting in a warehouse and somebody's ordering some stuff. I guess I can ship that book on Wednesday. Sorry, current guess is next month. That's the first thing. Second thing that can happen is I'm running with replication, multi-master replication, different users at different machines. I guess I can ship that book on Wednesday. I guess I can ship that book on Wednesday. I guessed I would ship the book. Oh no! Sorry, current guess is next month. I want you to observe something with respect to apology-oriented computing. Those two behaviors are indistinguishable from the users. This is life. And it is wonderful to sometimes take advantage of that because you cannot avoid the case on the top. And so that allows you to use replication and the funkiness of it because the reality of funkiness is the reality of funkiness. Does that make sense? Eventual consistency is nothing but an assertion of goodness. I didn't say it's bad. It doesn't tell you anything. Eventual consistency says when you and I have all the same input, we've seen the same stuff, then we'll have the same opinion. Doesn't matter the order in which we've seen it, we will land on the same conclusion. And so this quote from Maya Angelou is fun. You are the sum total of everything you've seen, heard, eaten, smelled, been told, forgotten. It's all there. Everything influences each of us, and because of that, I try to make sure my experiences are positive. Eventual consistency doesn't tell you how to be eventually consistent. It just says you'd better be or you have a bug, right? And so kind of isn't that useful, but it's okay, right? Let me give you an example of eventual consistency really working. I have 5 replicas here, and I'm trying to send to that first one. And so if I've done it right, the probability that it processes the work is much higher on the first one than it is on the others, but the other ones are there to pick up the slack. So ship Jim a book. Shipment ID is X. Great! He hears ship Jim the book, and he jumps the gun, and he says shipment ID is Y. Well, we have a business rule which says because X is less than Y, we will cancel Y. Again, that's a business rule. We've programmed it into our eventually consistent reconciliation. So now we've sent X, we've sent Y, and we are going to cancel Y. Okay? That ends up being predictable, acceptable behavior by the business rules. And we want to make it low probability, but that's got to do with how you handle the messaging. You want to make it low probability because it's a little expensive, but it's completely correct in behavior. And so now this guy sees all of that, and he says, oh no, cancel. And then you get down the road, and he eventually sees the 4th and the 5th ones see the cancellation in a timely fashion so they don't have to reissue it. And that's why it says, whew. Conclusion. Don't sweat the details, especially his. Try not to worry about how a partner application works. You have an interface, that's all you need to know. To heck with his inner soul, inner child, or psychic motivations. Did I get the right message back? And did you ship the shipment or whatever it is we're working together on? I don't care how the heck you do it. I don't care what language you're written in. I don't care if you light incense to do it. It's like whatever, okay? Your partner application may treat you differently than it treats others. All that matters is the face you see. You don't care if someone else gets different behavior. You don't care if it's someone else who's a different business partner. You don't care if it's someone else who is a different employee of the same company with different security authorization. You don't care. You care about what you care about. Worry about the internal details of your application and the protocols for his application. ACID 2.0, can you be associative, commutative, idempotent, and distributed? Can you cope with usually ships in 24 hours? I love usually ships in 24 hours, but it tells me nothing whatsoever. It's a probabilistic thing that's useful when I'm making decisions, but there's no promise whatsoever. Can you cope with that at a loosely coupled environment? Subjective consistency. Each application only knows what it knows. You can have a loosely coupled partner, but you only know what he told you last time you chatted. You can have a replicated self, evil twins or triplets. You may have heard something and done something they may have that you don't know. You can have an open-nested relationship that masks details, maybe another loosely coupled partner, maybe inside of your own belly like the bee tree is, right? Or the same on the same machine. Taking an action may increase your uncertainty or risk. You can choose to overbook, make a commitment you can't fulfill. You can take an action which depends upon that partner doing a matching decision. Now you have to cope if they don't do their part. Okay? A well-designed application only takes applications consistent with its business rules. You have to formalize the business rules. You have to make sure you live within them, even when you're, replicated and crazy, even when you're talking to some guy who's a Yahoo over there, right? And you have to figure out how to live within your business rules. Those business rules will intrinsically incorporate uncertainty, or you'd better not be a distributed, loosely coupled system. Except you can do synchronous stuff and you have less uncertainty, but asynchrony really gravitates that issue, really accentuates that issue. Subjective consistency. Based on what I know here and now, make the best decision I can. If I mess up, I'll deal with it later. So takeaways. Just as an aside, I've been doing presentations for 25 years or so at big audiences. This is the first slide I write and the last slide I present, because it focuses what you want the audience to remember to allow you to design the presentation. Okay? Gray and Reuter define consistency as the actions don't violate the integrity constraints. What are the integrity constraints for apps and different portions of an app? Consistency is being stretched because of a number of styles of new composite systems. Loosely coupled participants, where part of the apps are at a distance, no spanning atomic transactions. Replicated apps, some parts of the application have multi-master replicas. Open-nested participants, where the layers of abstraction separate bigger transactions from littler ones. Each participant, each layer has to be consistent from its own perspective. The B-tree manager is consistent with the inserts and updates, doesn't give a rip about the overarching transaction. The record-oriented transaction has a set of records to change, doesn't give a rip about the B-tree split. Okay? Never take an action that violates your own personal constraints. Squinting at the definition of consistency in transaction can give you increased concurrency. ACID 2.0. Eventual consistency. If you know what I know, you'd have the same idea, I have the same idea. That's all consistency means, eventual consistency means. And myopic side effects. There's no side effect that I'm aware of. That's your problem. That's what open nesting says. Subjective consistency is, given the information at hand, make the best decisions you can. Memories, guesses, and apologies. Do my best with what I have and remember what I did and what I've heard. Don't worry about ordering and retries as I make my decisions. Ensure my constraints are met. Selfish constraints. Ignore your constraints that don't affect me. So the only other thing I want to tell you is this is not what I'm working on at work. This is just fun. But I am working on really fun database and storage problems, and we're hiring at Salesforce. So, but other than that, I get a little ad. Okay. I guess it's time for questions. I did finish on time, given I started 10 minutes after the hour. 50 minutes, you asked for it. You guys asleep? I'm asleep.
It's actually probably worth asking a few questions because unfortunately Pat can't stay around for all.
No, I can't.
Yeah.
I actually killed myself writing this, and I'm behind at work. And we're buying and selling a condo, so it's like my wife's like, what? But fortunately, I live walking distance, so.
If you're all feeling a bit shy, what I probably would do is Pat's really good guy, walks in, he's the friendliest guy in the world, just grab him when he's down in the next coffee break, which is in about 2
But remember,
minutes.
I'm married when you grab me.
And just asking those questions, guys. I think it's probably the right way. And part of what we're trying to do here is just break down those barriers between us, the audience, and the speakers. There's no walls here, so if you just feel you want to speak
Yeah, come on up.
just do it.
I'll give you a hug.
Just go up
If you
and
come
do
up
it.
on stage, I'll give you a hug. I'm actually not kidding. I'll go down there and give you a hug. I'll give you a hug. Aww. It's all fun. Come on. What do you guys... Did this stuff make sense? Yes? I know the CRDTs, are they just academic? Are they in use? I know that Basho with REAC is investing intensely in them. I don't know too much about the details of the state, but I know that they're giving talks about them, and if you go to their recorded sites for Recon, they've got multiple presentations about their implementations of infrastructure to support CRDTs. But again, I don't know the details about it.
We've actually got a lightning talk today, just about that.
Oh, is there a CRDT lightning talk?
Chris, here somewhere, yeah, we've got a lightning talk from Basho today about that as well.
Oh, cool. So I give you some ads. It's all good. Other ones. Come on, guys. Ask me, what? Come on. Ask me what it's like living in San Francisco. Come on. Ask another question. Yes?
I'm still not really clear on that one sentence about eventual consistency. If you knew what I knew, I don't know what you know. How do I know what you know?
So the question is about my, one sentence of eventual consistency. If you knew what I know, how do I know what I know? Is that a fair paraphrase of the question? Okay. So all I'm saying is that eventual consistency says once every replica has received the same set of knowledge, if you turn off the activity and let it all settle down, okay, they'll all end up with the same answer. Okay, now in a real ongoing distributed system, you never quite settle down. That doesn't concern me. But the problem that I find, the term's fine, but it doesn't tell you how to do it. It doesn't tell you how to make sure that if you, my replica, got something before I got it, and then later on I got it, how to make that work. Okay. It's an assertion that you have a good property. And that's fine to have an assertion you have a good property. But the next level of goodness is to dig into how the heck do you create disciplines and rules that can get you closer to that. And so, as an industry, we are not to the point where we can say, here's a piece of work and here's the message style that goes with it that will automatically cause eventually consistent behavior. I can say it at a high level, and I mean it with atomic associative, commutative, idempotent, and distributed, and I mean that, but not very many people can translate that down into a running application. And what I'm looking forward to as an industry is when we can create an environment where you can write a program and the system can say, oh, it's got these properties. And then you can just behave in a replicated fashion because the system examined the properties of your components so that it was known to be working, right? And abstractions for expressing those invariants so that the system can enforce that you don't do more operations than can meet the invariance. But I want to point out, I don't care what your invariants are in a replicated system, you can only probabilistically meet them because you literally don't know what your evil twin has done. You don't have a clue. So you can't analyze based upon that knowledge that you're going to find of what's been committed by your evil twin. Did that make sense? You can actually do a really good probabilistic analysis based upon timings and behaviors and so forth, but you can't have certainty. Did I answer your question?
Yes.
Okay. Yes?
What is the principal difference between locally coupled and nested participants? They look very similar, but
What's the difference? What's the principal difference between loosely coupled and nested participants?
yes.
Loosely coupled systems are hard to build without open nesting. Open nesting can work in a centralized environment. For example, the B tree in the database. So there you're not even going across process, but you do have abstractions of what it takes to manipulate things. Another example is inserting something into a hash table. You put something into a hash table and it creates a legitimate hash table, right? But I have, symbol table operations where I'm inserting something and later on failing and then removing something in some cases, things like that, right? And so you can have open nesting inside of an environment. You typically want it in a loosely coupled environment so that most of the abstractions are hidden if you can build it properly. But it is not necessarily there in a loosely coupled system. And most people who talk about things like rest and so forth don't speak about open nesting in ways that I wish they would. Did I answer your question? So you don't have to have open nesting at a loose coupled environment. You simply have to have independent transactions that are committing. Okay? It is not atypical for there to be a loosely coupled, an open nested relationship in a loosely coupled system. That's not unusual, because I'm doing my thing and you only see a little bit of what I'm doing, and when you cancel, then I undo it, and that's very much an open nesting behavior. But they are different. Did that hang together? Okay. Any other questions? Yes. Okay, I see now. So the question is, I covered a bunch of concepts. Is there a framework out there that is implementing this stuff? And not to my knowledge, other than React and CRDT is a little bit, and so, but that's not completely all of these things. And I am not kidding you. This is not my day job, okay? This is just stuff I think about while walking home from work sometimes, and things that I've on and off for 15 years been interested in. And this twist of looking at it subjectively is not one that I've had before, although I've written other papers on eventual consistency and replication. But there's no project that I know of. If someone wants to start one, I'd like to keep in touch and give support, but it's just, for me, fun. Any others? Okay, I heard one. Mr. John.
One thing you didn't talk about, Pat, is anti-entropy. How does that interact with these kinds of concepts?
So the question is, I didn't talk about anti-entropy, and so just to make sure everyone knows what anti-entropy is, if you have lossy communication between replicas, is the typical way of looking at it, how can you say, what do you have, what do I have? Oh, you've lost this. How do I get that? Now, I'm totally enthusiastic about anti-entropy from the standpoint of making sure that the set of messages have been communicated to the replicas. I was just not talking about that, and I asserted the existence of at least once delivery combined with at most once processing to give you exactly once, and anti-entropy is a scheme to enhance that. Did that answer your question? Anti-entropy is a beautiful write-up in the Dynamo paper from SOSP in 2007, which was a fun project that I was privileged to be down the hall from, giving them garbage about it when they were building it. Anyone else? Yes? When you're building the distributed systems, is the emphasis more on technology and more on the business side? I think it starts with the business side in most environments, and then you get some crazy guy who doesn't always wear shoes to work who builds out the technology. And a disappointment of mine is that there's not yet ubiquitous platforms that abstract these things so that the guys doing the business don't have to build as much of their technology one-off. Inevitably, when you build your technology one-off, it does not have the full implementation that you do if you build it once to go in many places. What I've always seen in this industry for the 36 years I've been working in it is somebody gets an idea and they build an application which needs some plumbing, and that's cool, and they build it and it's great. Somebody else builds something kind of similar but completely different plumbing, and somebody else does it, and then someone stands back and says, wow, there's a pattern there. And then they build something which is designed to be more general and productize that, and that kind of moves the industry to a new level. TP monitors were that way, for example. There's just a lot of things that you're seeing now. You're seeing web scale things and so forth. You're seeing Hadoop is very much the same way. And so I would love to see someone build out a platform for loosely coupled systems that can empower businesses to do these things. So far, it's just done one-off over and over again. Does that answer your question? Is someone saying something? Okay, I think that's one more. Oh yes, there. I'm sorry.
So in multiple apologies, how do you determine which ones are
In multiple apologies, how do you determine which one to take? Dude, if somebody's apologizing, you're doomed. You just take them. I mean, it's like he's saying, I know I told you I would do this. I am not going to do it. You're just out of luck.
But if you have multiple of them.
As in the guy who's issuing multiple of them? Well, he's got his own business rules. You know, it might be this is a platinum card member, so I'm not going to apologize to him, right? Or it might be that I'm going to apologize to the last one in. It's up to the business to define those rules. And if you've ever flown on an airplane, you know it's unfair except for to those who have the most miles, right? And so that they will, I'm not kidding. If the airplane's too full, you know, you are not going to take the million-mile flyer and boot them, right? You're going to take, you know, grandma who's on her first trip in 20 years. Does that make sense? That's up to the business on how you organize your apologies and who you give them to and who you don't. Okay? And that would, again, if you're building a general platform, how do you codify that? I don't know. You would have to have some plug-in that would let you decide those things. Okay? Thanks for your time. You guys are fun.